Welcome to lecture number 412. This lecture is based on estimation and interpretation of multinomial logit model in STATA. I welcome you. Let me share with you the details of the data set and the model that I am going to estimate and interpret. In this model, yi is my dependent variable, but now it is a multi-categorical dependent variable. It has 5 categories, and it represents health status having 5 categories. 1 is equal to excellent, 2 is equal to very good, 3 is equal to good, 4 fair, and 5 is equal to poor. Age is my scale or numeric explanatory variable or regressor, and heart attack is a binary categorical predictor variable which is equal to 1 if a person had a prior heart attack and 0 otherwise. The sample size in this data set is 10,351. So I'll go to data file, and for that I will have to open my STATA, and the file has already been loaded. It's here. So first of all, let me tell you, I'll be using 3 variables. The dependent variable is health status, and that has 5 categories as I mentioned earlier, and then I'll be using age as my continuous independent variable, and finally I'll be using heart attack as my binary categorical explanatory variable which has 2 categories. A person, it is equal to 1 if a person had a prior heart attack and 0 otherwise. So let me describe my data. The variables that I'm going to use. So this is the description. Now let me label list health, and here is the list of the labels of health. 1 is equal to excellent, 2 good, very good, 3 good, 4 fair, and 5 poor, and this dot shows the missing categories. Now let me list the label list of the prior heart attack. It is equal to 0 if a person didn't have a heart attack, and equal to 1 if a person had a prior heart attack. Now I would like to use a multinomial logit model for health. So for that I am going to categorical outcomes, and I'll do this multinomial. My dependent variable is health state. It has 5 categories, and for this I'll use age as my independent variable. Since this is continuous variable, so I'll click on this and I'll add it to this, and okay, and I'll submit. So this is my multinomial logistic regression model in which I have only one continuous variable. So the command is mlogit health state age. These are the iteration, and these are the model level statistics, and these are the coefficients of age for those having excellent health category, and this is the coefficient of multinomial logit model for an individual having very good health category, and so on. Now let me go back to the command, and let me add another variable, and that variable is health state. Sorry, that should be heart attack. So here is my variable heart attack. Since this is not a continuous variable, so I will not check this box. I'll add this to where list and OK, and now I will submit. So here are my results. Now the command is mlogit. Health state is my dependent variable, age is my continuously variable, and I dot heart attack is the categorical binary descriptive variable, and I dot in front of this variable means that the STATA treats this variable as a categorical variable. These are the iterations. These are again the Monte level statistics, that is log likelihood chi-square test result. This is its p-value. This is pseudo r square. This is log likelihood, and these are the other various coefficients for the 5 categories: age and heart attack. Now, since these are coefficients, and it will be very challenging to explain this, so I can change these into here it says report coefficients, and I want to change these coefficients into relative risk ratios. So I'll check this and then I'll submit. So here are my results, and now the command will be a little bit different. I can show it to you. Here is the command. It says mlogit health state age I dot heart attack and comma RRR relative risk ratio, and after this I can run the same multinomial regression model, but I want to change the PACE category into poor. So now previously this was the base outcome, now poor is the base outcome, and these are the coefficient, and for the various health categories. So again I can go back to this, and I'll change this to submit. So now instead of coefficients I have a relative risk ratio. So these are now relative risk ratio instead of coefficients. Since it's very difficult or challengeable to interpret these results, so I would like to change this into margins. So let me go into, but before that let me also use the interaction effect with this. So let me go to this, and this time I'm using its interaction 2a. My first variable is age, and since this is continuous, so I will check this, and I will also add another variable, that is heart attack. Since this is categorical, so I am not going to check this, and I will do this, and now it will give me the interaction effect also. These are the main effects of age, these are the main effects of health, and these are the interaction factors of age and health for all these. And since I had changed the coefficient into relative risk ratio, so now these coefficients are relative risk ratio. Now I can do that shortly. Let me do this, and here instead of main, and let me use 2a full factorial, and I'll do age, and I'll check this, and I'll use health state, sorry, heart attack, and I'm not going to check this. I will also delete this, and I'll add to variable list. Now this command will exactly do the same thing that I did earlier with the long command. Now submit. So these results are exactly the same as I did before, and I can show it to you. Now here the command is mlogit health state c.age double hashtag heart attack and relative risk ratio, and here this long command produced these results, which are exactly produced by this short command, where we have two sharp hashtags. Now let me calculate the marginal predictive probabilities for heart attack, and these are the marginal predictive probabilities of those who have no heart attack and for those who have heart attack. So this probability, the probability for someone to have excellent health category, given that he has not prior heart attack, is this much. This is almost 24% as compared to 3%. Similarly, this is the marginal predicted probability for the individual having very good health, given that he doesn't have heart attack, that is almost 26% as compared to 4%, and so on. After this, I can tell STATA to give me the marginal predictive probabilities of heart attack with at different age, and I can also make a plot of this, and these are the adjusted predictions of heart attack with 99% confidence intervals. So let me go here, and I can change some of the things here. So these are the probabilities, and after that I can so now I created two different plots. One is for those who didn't have prior heart attack, and this one is for those who had heart attack. So these probabilities are different, and after that I'll do this. These are two separate graph, one for no heart attack and one for having heart attack, so we can compare side by side. And after that let me I removed the confidence interval and the dot from these two diagrams. Now we have connecting lines without dots and without confidence interval. Now these are okay. After this, I just made these lines thick, and the command is there. Let me show the command to. This is the command: margins plot x dimension at age, graph dimension heart attack, NOC, recast line P. So this is the command for making these thick. And after that, I can also show again. This is the comparison of these again for the 5 categories, and the lines are thick. Finally,